Interest rates. So far we've looked at interest rates in a couple of different contexts, but we need to be clear about how an interest rate is being quoted. The three main kinds of interest rate quotations that we might come across are the APR, which stands for the annual percentage rate, R, as shown in the time value of money formulas, which is the interest rate per compounding period, and the EAR, which is the effective annual rate. The APR, or annual percentage rate, is an annual rate that is typically quoted by financial institutions. It does not take into account the effect of compounding. A financial institution certainly should tell you how often interest is compounded, but they may quote the same annual percentage rate for different kinds of compounding. If we are given the annual percentage rate, but we need to work out the interest rate per compounding period in order to use one of the time value of money formulas, we just divide the APR by M, where M is the number of compounding periods per year. We've been doing that a number of times in previous modules. So let's do a simple example of that. Your bank quotes you an APR of 9.7% per annum, compounding quarterly. We know that we can't just use 9.7% in the time value of money formulas because we need to calculate R, the rate per compounding period. So given that this is the formula, what is the value of R in this situation? The APR of 9.7% is divided by 4, the number of compounding periods, so the R that we would use in our time value of money formulas is 2.425%. We now turn to the effective rate, or the EAR. The problem with the APR is that it ignores the effect of compounding, and as we've seen by some of our previous examples, the rate of compounding has an effect on the future value or the present value of a cash flow. Consider these four alternative interest rate quotations: 10.8% compounded annually, 10.5% compounded quarterly, 10.2% compounded monthly, and 10% compounded daily. The APR is different in each case, but if we are, for example, borrowing, we don't necessarily go for the one with the smallest APR. As we have seen in previous examples, the rate of compounding affects the ultimate value of a cash flow. The only way that we can make a comparison between these rates is to calculate the effective annual rate, the rate of interest that we are effectively being exposed to, taking into account the effect of compounding. The formula for the effective annual rate is this. The EAR is equal to 1 plus the APR divided by M, all raised to the power of M, minus 1. So let's use that formula in an example. Would you prefer to borrow at 10% compounded annually or 9.7% compounded quarterly? The only way to make a comparison is to calculate the effective annual rate for the 9.7% compounded quarterly. The 10% is already at an effective annual rate. If interest is compounded annually, the APR and the EAR will be exactly the same, and we could test that using the formula if we wanted to. So here is the formula for the EAR. See if you can calculate the EAR for 9.7% compounded quarterly. As we can see, the effective annual rate is 10.06%. Since we are borrowing, we would prefer to borrow at the lowest interest rate, and therefore 10% compounded annually is preferable. What this example is telling us is that if you borrow at 9.7% compounded quarterly, you are in exactly the same position as if you had borrowed at 10.06% compounded annually.